Good morning to all of you. We are discussing context-free grammar. So, in this context-free grammar, we discuss about the simplification of grammar. In case of simplification of grammar, we need to remove the unit production, the epsilon production, and useless symbol. We are removing for simplification of grammar. The important operations are to be carried out on the context-free grammar. And by removing all these, one can say useless symbol, epsilon production, and the unit production, we are making the grammar simplified, or we can say that the grammar become optimized. Why? Because the grammar, the CFG, context-free grammar, it may contain some extra symbols that may not require for the during this production or during the derivation. So there is a need to remove this extra production and to remove this extra variables, for example. And these variables, one can say that these are the useless symbol or epsilon productions or the unit productions, and we remove this and we are making it simplified, or we are calling it as a optimization of the grammar. Now, in the today's lecture, we are going to see the normal forms of the context-free grammar. Means we are going to normalize the grammar CFG. Now, what is the meaning of normalization, or how the grammar CFG can be normalized? So, as we have seen in CFG, at the right-hand side of the production, there are any number of terminals or non-terminal symbol, right? And we need to normalize such grammar. So besides reducing the grammar, it may also be useful for imposing certain restrictions on the form of the remaining production. Means up till now, what we have seen just to remove. Means we have just seen to optimize the grammar. Now here we have to normalize the grammar. Means we are further we are normalizing it means we are actually imposing certain restriction on the form of that particular grammar. So there are certain standard ways given by different scientists for writing reduced or optimized CFG. So there are two scientists, they propose two different format how we can write this particular CFG, right, context-free grammar. These are called as the normal forms. They are popularly known as the normal forms, right? So see here, so when the productions in grammar G satisfy certain restrictions, yes, then G is said to be a normal form. Means on the right hand side, you know that right hand side and the sorry, this is the left hand side of the grammar and the right hand side of the grammar. So there are certain rules on the left hand side, which how many terminals as non-terminals on the left hand side, how many terminals and the non-terminals to be on the right hand side. So depending upon certain restriction, depending upon certain rules, the grammar is normalized, right? So that means there should be fixed number of terminals and non-terminals in CFG. Fixed number of non-terminals and terminals in the CFG. We will discuss two most widely used normal forms proposed by these two scientists, Chomsky and Gravis normal form. The Chomsky is the name of scientist, Noam Chomsky, as already we have seen, and the another scientist, that is nothing but Gravis. He has proposed the Gravis normal form. So let us see the Chomsky normal form first. Chomsky normal form, in the Chomsky, Noam Chomsky, the creator of CFG, had imposed the restriction that the RHS of the production in the CFG can have at the most two symbols or two non-terminals. So see the Chomsky normal form, you will find that this is nothing but one can say this is nothing but the format. So on the right hand side of the production, there must be at the most two non-terminal. So this normal forms or the normalization means what we are doing actually here, we are imposing the restrictions. Means number of terminals and number of non-terminals, we are limiting this number either on left hand side or on the right hand side. So the Noam Chomsky, he has decided that, or he has proposed the rule that on the right hand side there must be at the most two non-terminals there. So I can, if I have A gives me BC, then yes, it is correct. It is having it follows the norms, and A gives a small a, only one non-terminal, means yes, I can say it is in the Chomsky normal form, or the grammar given CFG is in CNF. Now remember this term CFG and CNF. CFG into CNF. context-free grammar. This context-free grammar, this is, we first simplified the context-free grammar, means we have removed all the extra symbols, whatever may be in the grammar that are not taking part in the production rules. And now that simplified grammar, listen it carefully. Once you simplified the CFG, then the simplified grammar can be converted into the CNF, that is Chomsky normal form. And the forms tell us that on the right hand side of every production there must be at the most two non-terminals. So if I write A gives me B, C, capital D, these are the three non-terminals, then this is not in a Chomsky normal form. Getting this point? So to have the Chomsky normal form, there must be only two non-terminals on the right hand side, and there should be one terminal on the right hand side. And on the left hand side, there must be only one non-terminal. On the left hand side, it must follow only one non-terminals. On the LHS and RHS, max at the most two non-terminal, means only two non-terminals or one terminal. So if the grammar follows this rule, we can say that this grammar is in CNF, means it is nothing but it is in a Chomsky normal form, right? So thus we can say that CNF allows either two non-terminals or only one terminal on the RHS of the productions in the CFG, that is context-free grammar. So, and any CFG, any context-free grammar can be converted into CNF by imposing the following restriction. Now let us see how to convert the given context-free grammar into the Chomsky normal form, that is CNF. So there are some steps we have to follow. So see these steps or rules. The CFG should not contain null productions or unit productions. So first remove all null and unit productions, right? So the very first rule is that the given CFG, it must not contain any null production or unit productions. So we have to first remove all null productions as well as the unit production. The second rule we have to follow for conversion of CFG to CNF: remove the terminals from the RHS if it contains more than one terminals. If it contains more than one terminal, say for example A gives AB, so more than one terminals are there, two terminals are there, then we have to remove one terminal, so that on the RHS there should be how many terminals? Only one terminal, right? The next rule says that these terminals may be replaced by a new non-terminal. So this AB, small a, small b, you can have A1 gives you B, and later on you can accordingly you can form the rule. So these terminals may be replaced by a new non-terminal. Restrict the number of non-terminals on RHS to 2 only. We have restriction on the non-terminal on the right hand side must be 2. If any productions contain more than 2 non-terminals, then so if what happens, suppose if it contains, suppose A consists of B, C, D, so it contains more than 2 non-terminals, then using the new non-terminal we may convert the production into CNF. So if I take that some new non-terminal like R1, for example, R1 gives me say for example CD, so I can, this rule be converted that A gives B R1, so this is in a CNF, and this R1 gives CD, it is in a CNF, right? So it is a very simple step. So these steps we have to follow while converting the context-free grammar into the Chomsky normal form or the CNF. So first, the null productions are there or unit productions are there. The steps already we have discussed: how to remove the null production, epsilon production, as well as the unit production. A gives B, NT gives NT on both the side. Then remove the terminals from the RHS. If there are more than one terminal, then this one extra terminals must be removed. And if restrict the number of non-terminals on the right hand side. If there are more non-terminals, then you have to restrict this number. And if the productions contain more than 2 non-terminals, then using the new non-terminals, we may convert the production into CNF. Getting this point? So for converting the CFG, that is context-free grammar, into Chomsky normal form, these rules we have to follow. So observe it carefully, read it carefully once again, and we'll start converting. We'll see some examples how to convert the given CFG into CNF, right? So see, this is the first example. So from this example, it will becomes more clear to all of you. So grammar is given S. Now how many rules are given for this CFG? First rule, S gives A as A, S produces B as B, S produces small a, S produces small b, S produces AA, and S produces BB. So 1, 2, 3, 4, 5, 6 production rules are given here. So first step, simplification. Now observe it carefully. We have to follow this first step, that is simplification. Grammar is already in a simplified form without having any epsilon production. Yes, as there is no epsilon production, there is no unit production, and there is no useless symbol. So we can say that the grammar is already in a simplified form. Getting this point? So first, for the given, so it is very important. For this is very important. Always there is a question in theory examination to convert the given CFG into Chomsky normal form. So for this, simply first step we have to follow that. First, simplify the grammar. Simplify the grammar and then convert the grammar into normal form. Right. So simplification means what? Already we discussed that for the grammar simplification, we have to remove epsilon production, unit production, and useless symbol. So observe the grammar. By observing the grammar, we write in a step 1 that as the grammar is already in a simplified form, without it does not contain any epsilon or unit production or useless symbol. So directly start to convert into the normal form. So in the step 2, we will directly start to converting into the normal form. So how? So we have only 2 types of productions required. So we require the production that is nothing but A gives BC. This is example. This is example. We require the production. They must be in this format. A gives BC and A gives A. A gives BC and A gives A. So start with the terminal symbols and add 2 productions as. So always start with the. So remember here, if you want to start here, you have to always start with the terminal symbol and add 2 productions. You have to add 2 productions by adding 2 non-terminals for the corresponding terminals. Remember, so once again, listen this, you have to add 2 non-terminals for the terminal. So I will take R1, capital R1 as a one non-terminal and capital R2 as another non-terminal. So R1 produces A, small a, and R2 produces B. So this is the first step. So take the terminal first and assign new non-terminal or make the new production rules for producing that terminal symbol. Just like here, R1 produces A and R2 produces B. So R1 and R2, they are newly introduced non-terminals. We are introducing new non-terminals, right? So the grammar becomes, by adding these 2 rules with the 2 new non-terminals, the grammar becomes S gives R1 S R1, because here A is replaced by this, A is replaced by R1, this another A is replaced by R1 here, so this becomes R1 S R1. Then R1 gives A, S becomes R1 R1, because this double A now it is replaced by R1 R1, right? And this B again you are replacing, so next BSB you are replacing by R2 SR2, right? This is the rule. Then R1 gives this is here R2 gives B and S gives R2 for this BB it becomes R2. Getting this point? Observe it once again carefully how we are converting the CFG into CNF. Once again you will just observe it carefully. Simplification. So grammar must be in a simplified form. There is no unit production, no epsilon production, or no useless symbol. So we directly start converting the CFG into CNF, context-free grammar, into Chomsky normal form. So first step means this is the example we need to bring. We need this particular format. Every rule, each and every rule must be in this format. On the RHS there must be 2 NT, and on the RHS there must be at least only one terminal, right? So for what we are doing here, first we introduce 2 non-terminals producing a terminal A and terminal B. So R1 is a new non-terminal we take here, and R2 is another non-terminal we took here. So R1 gives A and R2 gives B. So just rewrite the grammar again. So after rewriting the grammar, we get this rule 1, rule 2, rule 3, rule 4, rule 5, and rule 6. The same 6 rules we have rewritten with the help of this new rule, right? And now we observe that this is already in a CNF. R1 gives A, it is already in CNF. R1 gives B, it is already in CNF. Then S gives R1, S gives R2. These are already in CNF. Now, which rules are not in CNF? Observe this grammar. So this particular rule and this particular rule, they are not in CNF. Then we have to bring these 2 rules into the Chomsky normal form. So for that, we again introduce more non-terminals. We are able to introduce more non-terminals. See here. So from the above productions, there are only two productions. They are not in CNF. That is, S gives R1, S R1, and S produces R2, S R2. So we introduce two new variables as R3. So this is the step. You have to add the new non-terminals here. You have to just go on adding new non-terminals. So S3, that is nothing but SR1. This you take as a R3, and R4 is nothing but your SR2. You are taking as a R4, and your rule becomes now, so S becomes, so this S become R1, R3, and this particular S produces now R2, S is not there, R2, R4, R2, R4. Getting this point? So hence the equivalent grammar. So write the answer here, write the answer. The equivalent grammar in CNF, that is Chomsky normal form, is S gives R1, R3, this rule, then R2, R4, this one, then R1, R1, R2, R2, and A and B. So these are the 6 rules: 1, 2, 3, 4, 5, 6. Okay. Now write down the rules which we have added freshly or newly. So that is nothing but R1 produces A, R2 produces B, R3 produces SR1, and R4 produces SR2. This is our final answer to the question. This is the final answer. Correct. Getting this point? So for converting, so what we have learned now, so for converting our context-free grammar to the Chomsky normal form, the very first step is the simplification. And after simplification, if the grammar is in a not simplified form, then we have to simplify. Then after simplification, then we have to add the NT to bring the grammar in the format like NT produces NT.NT and NT produces T. So this is the format of our CNF, that is Chomsky normal form, and we need to bring all productions in the given grammar in this particular format. So these are the steps, right? So we'll see another example. Convert the following CFG into the Chomsky normal form. So grammar is given: S gives BA, S gives AB, then A gives BAA, A gives AS, A gives A, then B gives ABB, B gives BS, and B gives B. So first see whether any epsilon production is there, unit production, or useless symbol. So by observing the grammar, I can write that grammar is already in a simplified form without having any epsilon production, unit production, and useless symbol, because there is no epsilon production here, there is no any unit production, yes, and there is no useless symbol. So there is no question about the simplification. Grammar is already in a simplified form. So in the second step, now convert the grammar into the Chomsky normal form. We can have only two types of production rules are allowed. Which are the two rules? That is nothing but A gives A gives BC, and A gives A. So see here, now the productions A gives A, that is this one. A gives, capital A gives small a, and capital B gives small b. So these are already in CNF. So I can introduce two new non-terminal here. Introduce two new non-terminals. R1 produces small a, R2 produces small b. So write down the grammar again. Write down the above given grammar again. So the grammar becomes S gives R2A. R2 is nothing but your B, right? And S gives R1B, R1B here. Then A gives R2AA. This R2 is nothing but your B. So this becomes R2AA, and the A becomes R1S. This is nothing but R1S, and this is nothing but your A as it is. Because this is in OK format. A gives A is it is in a correct CNF format. So don't write here R1. So that if you write here R1, so it becomes in a it produces the unit production. So we don't want any unit production in the grammar. So A is here as it is, and here R1BB, R2S, and finally B produces small b. So now here if we observe, so this rule is already in a CNF, this is in a CNF, this rule is already in CNF, then A produces small a, B produces small b, already in a CNF, and this R2A is also in a CNF, only remaining R2AA and R1BB. These two rules, they are not in CNF. We need to convert these two rules in the Chomsky normal form. So from the above productions, there are only two productions, they are not in CNF, that is A and B productions. So we introduce two new variables, that is R3 and R4. R3 is nothing but double A. You assign this R3 to double A and assign this R4 to double B. So your capital A becomes, now capital A becomes R2, and this A becomes R3. So R2, R3, and B, that becomes your R1 as it is, and double B is, now it stands for R4. It is very simple. It is very simple to assign the new non-terminals that like R1, R2, R3, and R4. So the final equivalent CNF becomes S produces R2A, R1B, capital A. See here, capital A gives us R2, R3. So this is R2, R3. It is taken here. Then R1S, it is in a CNF format, and capital A produces A. So if we observe S gives R2A, yes, two non-terminals, it is okay in a CNF format. Then S gives R1B, okay, it is in a CNF format. Then capital A produces R2, R3, yes, it is in also CNF. R1S, yes, it is also in CNF, and A produces A, also in a CNF. B produces R1, R4, this is taken here. So yes, it is also in a CNF, nt.nt. Then B produces R2S, nt.nt, also it is in a CNF format. And small capital B produces small b, it is also in a CNF format. So all production rules are in Chomsky normal form. So this is equivalent grammar to our given context-free grammar, right? So this is equivalent grammar which is given, which is same as that of given context-free grammar, right? So these are actually the steps how to convert the CFG into CNF, right? Let us go to the next slide here. And sorry, here also you have to write down the remaining rule, that is R1 produces A, yes, R2 produces B, again in a CNF, R3 gives double A, and R4 produces double B. All rules are in a context Chomsky normal form. See, next grammar. Now here, S gives A as A, B as B, small a and small b. Simplification, already in a simplified form, there is no need of any simplification is here. So step 2, add two variables as here. A gives a small a and B gives small b. Now here A is a new non-terminal. A is a new non-terminal and B is also a new non-terminal we are adding here. So in the previous example, we have taken R1 and R2. So here first we take this capital A here and capital B. So the grammar becomes S gives capital A, S capital A, capital B as small capital B, A B, and whereas A gives A and B gives B. So these are the this is the S, this is A, and this is B. These are the rules. Now we have to add more two variables as R1 equal to SA. For this SA, we are adding R1 as a new non-terminal or variable, and for R2 is for SB. These two terms we are adding R2. So the final grammar in the CNF, it is very simple. So I can write here AR1, BR2, small a, small b. These are the two rules we have introduced. First, that is A, so capital A produces small a, capital B produces small b, and R1 produces SA and R2 produces SB. So all these rules are in a Chomsky normal form. So I can say that this is the given grammar, the CFG, and this is the equivalent normal form of that particular grammar. Getting this point? Very simple. You observe it once again. You just go through, listen it carefully. So first, what we have done here. So for this A and for this B, so S it is a production like this. S gives A and S gives B. So what we did here, we just added two non-terminal, that is A gives A and B gives B. Right. Now to this two non-terminals, and add the and write this into the original grammar. So we'll get here S gives A, S A, and say for example B, S B, and A and B as it is. So for this SA we are adding R1, and for SB we are adding R2, and the resultant grammar become S gives. The resultant grammar becomes like this: S gives A, R1, and say for example B, R2, A, B as it is, and the newly added rules are A gives A, B gives B, and one more rule we have added like this: R1 gives us SA and R2 gives SB. So this is our actual answer to this particular question, right? It is very simple. There is no any difficulty. Just what we have to do here, we have to start adding the variables, or non-terminal with the help of this terminal symbol. Getting this point? Let us see one more example. Okay, simplification is use A and A gives SBA. The already in a simplified form. So directly production is gives A is already in a CNF. So what we have to do here, we are adding directly one new variable, that is R1 produces a small a. R1, capital R1 produces small a. So hence the grammar becomes R1 A R1 and R1, for example. So add one more variable R2 for AR2. This term it is now replaced by AR2. So the grammar becomes S becomes R1 R2 here. So this is so that's all about your this particular term, that is S. Now look at this second part of the grammar, that is A. So here R3, you take R3 as a B, so the hence the grammar A becomes A gives S R3 capital A, then SS and R3 R1, because A is nothing but your R1 and B is nothing but your R3 we are taking, right, and R2 is the value of AR1. So this is in a CNF. This SS is in a CNF. Now for this again we have to add one more variable R4. So R4 is equal to R3A. So for this R3A we are taking R4. So this A become SR4 double S and R3 R1. So entire grammar, all the rules are now in a CNF. So hence just write down the equivalent grammar in a CNF as S gives R1 R2 A and A produces SR4 SS R1. So these are the rules. This is one. This is second rule. Now A produces SR4 SS and R3 R1, and write down the newly added rule. Also you have to write down the newly added rule also. So R1 gives A, R2 gives AR1, R3 produces B, and R4 produces R3A. Right. So this is the way. Now let us go to the next example, number 5. See here. Now this example, epsilon sign is there. Now this epsilon is given here. Now see, first step is the simplification, and we have to simplify the grammar. Now grammar is not in a simplified form. It is not in a simplified form as it contains the epsilon production, because A gives epsilon, B gives epsilon. Now see it carefully, listen it carefully, and observe how it is being solved here. So definitely S gives epsilon. So how many? So first step is to eliminate the epsilon productions from the grammar. Now the given grammar, S gives A gives A epsilon, B gives BB epsilon. So this grammar contains the epsilon production. So for normalization, before going to the Chomsky normal form, we have to simplify the grammar. And simplification of the grammar means we have to remove the epsilon production, unit production if any, or the useless symbol if any in the grammar. So start removing the epsilon production, and we know how to remove the epsilon production. So steps in removing the epsilon production is that first find out the nullable non-terminals. Nullable non-terminals means that the non-terminal which goes to the null symbol, or which goes to the epsilon symbol. So here A tends to epsilon, B tends to epsilon. That's why therefore S tends to epsilon. So I can conclude that there are three nullable non-terminals, that is A, B, and S. The first step. And second step is that what we have to do here, we have to make the productions by making nullable non-terminals null. We have to write the, for example, S gives A, B, A, and how many these S is also nullable, then A is also nullable non-terminal, B is also nullable non-terminal. So we have to add the productions by making the nullable non-terminal null. So from this production, how many production we'll get here? We get here AB, where this A becomes null. We get here BA, making the first A as a null. We get AA, making the B as a null, right? Then after we get B by making the these two A as a null, we also get here A by making this last two BA as a null, right? And finally and S gives epsilon, but we have to remove this epsilon symbol. So we are not going to consider this S produces epsilon, right? Because we have to remove the epsilon production here. So see, nullable set of symbols are S, A, B. We obtain productions by making nullable non-terminals as a null. So we have to make the nullable non-terminus null. So SAB, from this rule we get the different rule like AB by making last A as a null, then BA making first A as a null, then A by making last BA as a null, then B making 2A as a null, and S produces AA by making B as a null. So these are the productions we got here, but here we are not writing S produces epsilon because we have to remove this S tends to epsilon. And from this A, this is one rule here. This one, from this rule we get another rule, that is by making this A as a null, A gives capital A gives small a, and from B, small b, capital B written as BB, because this B now becomes null here. This B is now null and this A is now null. So these two new rules we are forming here by making nullable non-terminals as a null. So collect all rules, all write all these rules. So hence the grammar becomes without epsilon productions like this: S produces ABA, AB BA, capital A, capital B AA, and A produces A, B produces BB and B. Now you observe that though we remove the epsilon productions, but there are unit productions like S produces A and S produces B. These are the two unit productions, and we have to also remove the unit productions. We have to also remove the unit productions. So S gives A and S gives B are the two unit productions in the newly formed grammar. So remove these unit productions by replacing their definitions. So A can be replaced by this total term, and this B can be replaced by this term, the definition of B or the production rules of that capital B. Hence the grammar becomes S gives. So same for this. Hence the grammar becomes, I write here ABA as it is, capital AB BA. Now this A is nothing but your capital A, it is replaced here, and BB and B, this is nothing but your capital B. These two unit productions are removed by their definitions, and capital A as it is, and finally A gives AA and A, small a, capital B gives BB and small b. So this is your simplified grammar. So I can say that this is the simplified grammar. So with these two slides, we have converted the given grammar into the simplified form. That means we have removed the epsilon productions and we have removed the unit productions. Now this grammar we can convert into the normal form. This grammar is now ready to convert into the Chomsky normal form. So see here, step 2. Now convert the above grammar into the CNF, that is Chomsky normal form. So S gives BA, capital ABA, take R1 as a BA, hence S becomes your AR1. So for this, just introduce R1 as a new non-terminal here. So your rule becomes S becomes AR1. Then S gives AB, S gives B, and S gives A already in CNF. This is okay in CNF. Non-terminals gives NT.NT. This NT gives NT.NT. This S gives NT.NT. Okay, they are already in CNF. This is also in a CNF. Okay, now next, now S gives AA. Now S gives this NT.T. Consider this rule here. We will define R2 for small a. Hence this rule becomes R2A. This rule becomes R2A, or here AR2, which is also in CNF. So S gives A already in CNF. Now S gives small b, capital B. We will define R3 for B. So for this terminal, assign new non-terminal, that R3. So rule become R3B. Hence we become S gives R3B. So this is also in a CNF, that is Chomsky normal form. So and S gives B is already in CNF. So collect all the rules. So consider the rule now consider the next production, that is A gives AA. So A gives R2A, where A small a is nothing but your R2, right? And for the this B becomes B gives small b, capital B. Now this small b is now R3. So this becomes B gives R3B. It is also in CNF. This is in CNF. Then A gives small b, capital B gives small b. This is also in CNF format. So you observe here all the rules, each and every rule we have converted to the normal form by introducing new non-terminal like R1, R2, R3, right? So finally we can conclude that collect all the CNF productions rules to integrate, and we will get the equivalent Chomsky normal form as, see here, S gives AR1. So here we have to just collect all the rules. Just now we have form here. S gives AR1, AB, BA, AA, R2A, R3B, AB. A gives R2A, A, capital B gives R3B, B, and write down what are all the new rules we have added here. The rule are R1 is equal to BA, R2 is nothing but small a, R3 is nothing but small b. This is the way, right? So this is our final answer. We can say this is our final Chomsky normal form, which is the equivalent grammar, right? So if we observe it, or if you seen it carefully, so you'll find that first grammar is simplified. We have removed the epsilon production, we have removed the unit production from the grammar. Now the grammar is formed CFG we have obtained, that is simplified CFG we have obtained. And once we have got the simplified CFG, we have converted that CFG into the Chomsky normal form. This is the steps. That's why the simplification of grammar is very much important. And once we got the simplified grammar, then we have introduced the two non-terminal new non-terminals, that is R1, R2 and R3. By introducing these three new non-terminals, the grammar is brought into the normal form. Getting this point? Let us see another example. You have to practice this example. You have to solve by your own, and you have to practice it. Once you practice it, then it becomes very simple. There is no any difficulty here. Now observe this. This particular grammar also contains the epsilon. So as it contains epsilon, means it is not in a simplified form. We have to bring it in a simplified form by removing the epsilon symbol. And after removing epsilon, suppose if any unit production introduced, we have to also remove that unit production from the grammar, and we have to make it simplified. And after simplification, then we can go for the normalization, or we can convert into the normal form. So step one is simplification. Grammar is not in a simplified form as it contains epsilon production. So first eliminate epsilon production. That is nothing but P tends to epsilon, Q tends to epsilon. Therefore S tends to epsilon, right? So nullable set of symbols or nullable set of variables, that is S, P, Q, 3 are the nullable non-terminals. So we have to obtain the productions by making the nullable non-terminals as a null. So from this first rule, that is S gives P, Q, P, it can be written by using the nullable non-terminal null, that is PQ, by making last P as a null. Then QP, that by making the first P as a null. S gives P, last two terms QP we are making as a null. S gives Q, 2P are becoming null here. And S gives PP, the middle Q now we are making as a null, and we are obtaining the rule S gives PP. And the rule P gives 0P. This is 0. This is not O, it is 0. So here these terminals are 0 and 1. Observe this. This 0 is one terminal and 1 is one terminal. Remember this point. And your NTs are nothing but your S, P, Q. These are your non-terminals, or they are variable, whereas your this 0 and 1 are nothing but your terminal symbol, 0 and 1. So this 0, 1, this is terminal and P is non-terminal. So it can be written as why? Because this P is now becoming we are making it as a null. And for the next rule, that is Q use 1Q. So this can be written as a Q use 1 only, where Q is now becoming null. So these new rules we have obtained here. So just summarize all these obtained rule and write in a simple format. So the grammar without epsilon production becomes this one, right? So S produces, capital S produces PQP, PQ, QP, PQ, PP, and P gives us 0P and 0. Q produces 1Q and 1. Now if we observe this grammar, it contains the two unit production, that is nothing but S tends to P and S tends to capital Q, capital. So these two unit production is to be removed by replacing this definition into, instead of P and instead of Q, we have to replace the definition, so that the unit productions will be removed and the grammar will become simplified. So now S tends to P and S tends to capital Q are the unit productions. Remove these unit productions. So S tends to P can be expanded as P gives 0P and P 0, whereas S gives 0P and 0, and S gives Q can be expanded as capital Q gives 1Q and 1. So S tends to 1Q and 1. Hence the simplified CFG, simplified context free grammar, can be written as S, capital S, PQP, PQ, QP, 0P0, this is replaced for P, and 1Q1 it is replaced for capital Q. This is capital P, right? And PP as it is. And the next term is your P gives 0P and 0, whereas Q gives 1Q and 1. So this is our simplified grammar. Now from here onwards, take this grammar for the normalization, or this grammar can be converted into the normal form, Chomsky normal form. So now convert the above grammar into the CNF as. So take the first production rule, that is S tends to PQP. So take R1 for QP. So QP, assign new non-terminal for these two NT QP R1. So the S becomes PR1. So this S becomes your PR1. Now next term is S gives PQ, S gives QP. They are already, and S gives PP. They are already in CNF. They are already in CNF. There is no need to assign any new non-terminal here. Now S gives 0P. Now S gives 0P, that is nothing but T and NT. This is nothing but your terminal, and this is your N non-terminal. So this is not in the format. So what we have to do here, we have to define one non-terminal for this terminal 0. So for this terminal 0, we assign this R2. So R2 produces 0 as a terminal. So the rule becomes S produces R2P. R2 is nothing but 0. We are replacing the 0 instead of this non-terminal. And so, and S0 is already in a CNF. Now consider this one, this rule, S gives 1Q. Now this is not in a CNF. This is not in a normal form. So what we do here, we assign one new non-terminal for this terminal 1. Now assign this R3 that produces terminal 1. So the rule becomes S becomes R3Q. The rule becomes R3Q. That is in a CNF format. That is in a CNF format. So S tends to 1, already in CNF. Now consider the next rules. That is P produces 0P. But 0 already we have assigned this R2. So this rule becomes P produces R2P, and P tends to 0 as it is. And now consider the next, that is nothing but your Q produces 1Q, but 1, what is the value of 1? Already we have assigned one non-terminal here, and that 1 is nothing but R3. So it becomes Q tends to R3Q, and Q tends to 1 as it is. So all the rules, I can say that yes, all these rules are in a normal form. So collect all these rules which we have formed here and write in a single form. So here collect all the CNF production rules, we integrate, and we will get the equivalent normal form as S produces PR1, PQ, QP, PP, already in a, this is in a CNF, this is in a normal form, this is in a CNF, this rule is also in a normal form. R2P we have form, it is a normal form. R3PQ, it is in a normal form. And S produces 0, S produces 1, that is means NT gives T, NT gives T. Okay, so I can say yes, it is in a CNF. Now P produces R2P, yes, it is in a normal form, and P produces 0, it is also in a normal form. Whereas capital Q produces R3Q, it is in a normal form, and capital Q produces 1, it is also in a normal form. And also don't forget to write down the newly introduced non-terminals and their rule. R1 is nothing but your QP, it is in a normal form. R2 is a 0, okay, no problem, it is in a normal form, that is nothing but NT produces T, and R3 also it is a 1. So these all are nothing but, these are nothing but your rules, these are nothing but your rules, new production rules that are in a Chomsky normal form. These are the rules in a Chomsky normal form. We have just converted it. Getting this point? So this is the way how to convert the given CFG. Always there is a question on this particular. Convert the given context-free grammar into the normal form, and do not get confused between CFG and CNF, where your CFG is nothing but your grammar, but this is nothing but your normal form. Remember this point. This is the normal form, and this is nothing but the grammar. Your grammar you are converting into the Chomsky normal form, right? And the steps are, the very first step, you have to first simplify, and after simplification, we have to simplification means remove epsilon, remove unit production from the grammar, then assign, take new non-terminal like R1, R2, R3, assign it to some terminal symbol like A, B, small a and B, and then go on converting, go on writing the format. In this particular format, NT must produces NT.NT means there must be only two non-terminals on the RHS, or NT produces T. So this format, fixed format, for CNF, always you have to remember, right? This particular format, always you have to remember that in Chomsky normal form, on the right hand side, there are only two non-terminals and there must be only one terminal on the right hand side. And each and every production in the grammar must be brought in this particular format, so that we can say that the grammar is in a Chomsky normal form, right? Okay, so questions are there. Convert the following CFG into equivalent Chomsky normal form. So first grammar is given, S gives 0, 1, X, capital XY, X gives 1, XY, and epsilon, and capital Y gives YX 0, capital X, epsilon, right? So here, yes, of course, it contains the epsilon symbol, means you have to first remove the epsilon symbol. You have to simplify it, means you have to remove the epsilon symbol. And after removing epsilon symbol, if it contains any unit production, then you have to also remove that unit production. I remember this point. X, Y, S, these are the entities here, whereas 0, 1, they are the terminal symbol here. They are the terminal symbol here, right? The next grammar is a simple one, A and B and A double S. The next grammar is S gives A, B, A, A, B, and comma, A gives A, S. The two rules are given here. This is the first. The second one. The next one is, now this is the another example. S produces 1A and S produces 0B. Again, 0 and 1 are your terminal, whereas A and B are your non-terminal. Capital A produces 1A, 0S and 0, whereas capital B produces 0BB, 1S and 1. So these are the four examples. You have to try it by your own. This is the context-free grammar. Just convert this grammar into the normal form, or bring this grammar into the normal form with the given methods in the presentation, right? Okay, so what we have learned in the today's session is the normal forms of the context-free grammar. Two normal forms, that is nothing but the Chomsky and Gravis normal form. And the Chomsky normal form we have seen in details. On the right hand side, there must be at least there must be only two non-terminals, not at least, but only two non-terminals on the right hand side and only one terminal on the right hand side of the grammar. Then we can say it is a Chomsky normal form. Then we have also seen the conversion of context-free grammar into Chomsky normal form, and how to convert the step by step. We have seen some examples on it. So course outcome attainment of the session, yes, to apply the well-defined rules for the syntax verification. So the very important topic today we have discussed. The reference book, always go for the standard reference book. Okay, so let us stop here.